Okay, so you're asked to find a formula for the nth term of the sequence. So you might think that there's no way to do this besides just guessing and pulling out formulas out of the ether. But actually there is quite an easy strategy to this kind of stuff. So first you break it into the numerator and the denominator. So you look at each part independently. Let's look at what's happening in the numerator. We're adding 4 each time. That tells you that you have 4n. 4n. So it's not 4 plus n, or n plus 4, or anything like that. N to the power of 4. No, it's 4n. Whenever you see addition of 4 and you have a sequence, you do 4n. If we were adding 3, we would do 3n, and so on. Okay, so that's part of the numerator, and but we're not done with it. In the denominator, we have an easy one. We have 3 to the n, right? Because each time, since for a sequence we plug in 1 and then the next integer after 1, which is 2, and then the next integer, and so on forever, clearly we're going to get this, right? Like plug in 2 into here, we're going to get 9, because that's 3 squared. We plug in 3, that's 3 cubed, so we get 27. So that's kind of easier to see. When you see this pattern of an exponential function, you should know, where it starts, right? You should be able to recognize this one. 3 to the n. Okay, but for the numerator, we're actually not done yet, because we had 4n, but we can't just leave it like that, because remember that our sequence starts with n equals 1. So if we were to plug in 1 for our first term, we wouldn't actually get 1/3, we would get 4/3. So we have to account for that by making our first term be 1. So how do we make this be 1? Well, just subtract 3. If you subtract 3, now we plug in 1 into n, we get 4 minus 3, which is 1. So that's how you get your sequence. This is the sequence.